The design and research experience gives the student the opportunity really to take on the role of the professional. The senior design experience is just the capstone on all of that. You are the engineer, here is some money, here is a design problem, here are your mentors, here is your machine shop. Well, get on with it.
We're building a device that's going to go on top of a rocket. It's going to fly up into the upper atmosphere and it's going to collect micrometeorites.
The clamps come down and clamp around the edges of the Teflon to provide a seal.
We wanted to create an antimicrobial surface that relies on very low levels of electricity. We have a battery set up to a cutting board that is going to sterilize, but it won't shock the user at all.
We are trying to get their engineering skills from theoretical to practical and let them apply all the knowledge that they have gained to real live problems.
The ChemiCard team is something that we do here for fun, and it's something that we do to perfect our skills outside of the classroom.
I really wanted to get a hands-on approach to chemical engineering. My goal on propulsion was to help develop some kind of way to actually move the car, and so that took the form of the Zinc Air Battery.
During the design day next week, they'll be able to showcase all the work they've done, their innovations, their proof of concepts and prototypes.
I'm part of the team AFRL, so that stands for Air Force Research Laboratory.
We had to build an all-terrain motorized wagon or vehicle.
We worked on patient transfer, and particularly what we built was essentially a two-wheeled wheelchair device.
Basically handle any loads that the Air Force wanted to transport over really rough terrains.
The goal of the project is to help biomedical equipment technicians in developing countries to repair medical equipment. Surgeons in low and middle income countries, they face a big challenge whenever equipment breaks down. In the app, we have Troubleshooting Guides, which are pretty much a series of yes or no questions that take the technician through identifying the problem with a particular device.
It's a great ecosystem for medical innovation because you have these talented engineers that are hungry to solve problems. And then on the other side, you have clinicians that are working daily with patients and are frustrated by not being able to do what they want to do.
We are working with clinicians at the Johns Hopkins Hospital, namely Christopher Brady, to develop a telemedicine solution for retinopathy of prematurity. Right now we're using the hardware system we developed, which is a low-cost, very compact indirect ophthalmoscopy system. If you create hardware that's very basic in every sense of the term, but then augment it with these new computer algorithms, I think it's the future of health in general.
Over the course of the semester, we can truly see them make a transition from student to engineer.
Engineering is an example of a very advanced discipline really, that's somewhere between an art and a science and a lifestyle choice. It's a community of established engineers and scientists and colleagues that raises up the next generation of engineers.
I felt more like an engineer because I finally got to apply all the skills I learned in my classes to a real project and get to try and make something for a client.
I learned what it was really like to be an engineer, what it was like to work in the field of robotics. It was really a remarkable experience.
It's a lot more difficult to build something than to design it. You know, on a computer you can make it perfect. It gives us an appreciation for the people that actually have to build things and do this professionally.
It's just like a fun way to see how engineering applies outside of the classroom.
It really showed me that there's a lot of untouched problems in the world and a lot of really great places to make a difference.